All right, these are identities that I need you to be familiar with and know. Sine squared plus cosine squared equals 1, right? As long as this angle is the same, so you could have thetas here, or x squareds, or 2x's, right? As long as these angles are the same, we have this identity. Same thing for tangent squared plus 1 is secant squared. You're going to need to know this as well. This one will come up often. You'll need to know sine of 2x is 2 sine cosine. So there's many other trig identities, but these are the 3 that I need you to know. You need to know that sine of negative x is negative sine of x, and cosine of negative x is just cosine. And this is just good old SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And tangent is the same as sine over cosine. Cotangent is cosine over sine, and then cosecant's 1 over sine, and secant's 1 over cosine. Basic things that you need to have memorized. Other things that I'm just assuming that you'll know, so just a quick review. Area of a circle, circumference of a circle, area of a rectangle, circumference of a rectangle, actually I guess I should say perimeter, right? Perimeter of a rectangle. Volume of a cube, and volume of a length, volume of a rectangular box, so length times width times height. All right, so this is really, really wrong, very, very bad math, right? This is not true. This is not true either, and this is not true. So these are all very wrong. Make sure that those don't happen on your paper. Okay, these laws of exponents, sometimes we hesitate. Oh yeah, am I supposed to add the exponents? Am I supposed to multiply? Let's just do a quick review. So when the bases are the same, you add their exponents. When the bases are the same and there's division, you subtract their exponents. This is the situation you multiply them, right? Then they're separated by parentheses. You can distribute this exponent to the a and the b. And a to the negative x is 1 over a to the x. If you've got the negative x in the denominator, a to the negative x in the denominator, that comes up to positive a to the x. All right, so let's play with these. So we'll get situations where we'll want to simplify to one fraction. So I've got x's and y's here, so let's do some subtraction. And we usually like to, doesn't matter, I guess, positive exponents or not. So let's just make everything in the numerator. So x to the negative 2, y cubed, I'd have x to the negative 4, y to the 5th. So moving everything to the numerator. So these two I will join together and add their exponents. So x to the negative 6. And then I'll join these two together, and that'll give me y to the 8th, adding their exponents. If I wanted to make positive exponents, it could be rewritten like this. So this is a fine answer, and so does this. All right. And the instructions about multiplying by the least common denominator are going to work for this following examples. These two here are just straightforward. So this here I'm going to distribute this negative 2 exponent. So I'll get x to the negative 6, y to the negative 2. And then here I'll have x to the 4th, y to the 8th. So distributing these exponents, joining these together. So I get adding the exponents of the x's together. X to the negative 2, adding the exponents of the y's together. I get y to the 6th. And again, if I wanted to make all positive exponents, I'd rewrite it like this. All right, so this one here, because I have subtraction up here, I'm going to invest the time to rewrite these as the fractions that they are. So now I'm going to follow the instructions with the help of multiplying the numerator and denominator by the least common denominator to get rid of the fractions. So I'm going to multiply numerator and denominator by x squared, y squared. And I'm going to cancel as I go. So if I take and distribute this to this first term, the y squareds cancel, so I get x squared. Distribute this to the second term, the x squareds cancel, so I get y squared. And in the denominator, adding the exponents, I'd get x to the 5th, and then y to the 6th. And that's as simple as it will go. I do have difference of squares in the numerator, but it's not going to cancel with anything. All right, for this one here, multiplying by the least common denominator will be x minus 1 times x plus 1, or x squared minus 1, however you want to think of it, but that will be the least common denominator. So distributing, canceling as I go, I'll get 1 when I multiply this times this term. Then if I multiply this times this term, I'll get a subtract x minus 1. Be careful with the subtraction. And then multiplying in the denominator, I'll get x plus 1. So then, just distributing this through, I'll get 1 minus x plus 1. So then the 1's gather together to be a 2. Whoops, a 2 minus an x on the numerator, x plus 1 on the denominator.